Welcome back, I'm Captain Xavier, and this is the next video in my 2023 New Year's Build Project Vlog. And I'm going to be picking up where I left off. Last time I got the switches and the Arduino all wired up so that I can, at this point, plug a LiPo in here and the Arduino will, in fact, turn on. Hola! Light. Today's goal, and we'll see how far I get, is I want to get this side of the connector wired up. So this is going to be connected to all the components in here and will be what connects them all to the front half where our switches and motors are. It'll make it much more convenient to disconnect the two. And so that's going to get wired in. It's going to snake around in here. Most of the things that are connected to here are then going to be connected to pin connector wires so that they can be connected to the Nerfduino non-permanently, so that I can easily take the Nerfduino out if I want to reprogram it or add more features or whatnot. So nothing, everything that connects to it will be connected with jacks or pin connectors of some kind. The trick will be making sure that nothing comes loose. So I'm going to be looking at a couple of options to how to better secure them when they're on there. I might just put a little bit of tape on or something. Who knows? It may not be necessary depending on how everything fits in. There are going to be a number of things on this side that require full 12-volt power. This is designed for cars, so I have no doubt that these wires can handle 12 volts, especially given the relatively low amperage that we're dealing with here. But most of the things over here are going to be signal wire. Both of the switches here are signal wire. The LED in here is 5 volt. It runs off the Arduino, so it's practically signal wire. The ECSs are signal wire, but then there is also 12 volt power for all of the motors going on in there. So this wire is our pusher motor wire, and it does not need to be anywhere near that long. It will be connecting to one of these pairs of red and black. Hopefully I can figure out which red and black are which. We will see. That's clearly slightly twisted. There we go. I will be hitting this heat shrink and shrinking it up once I'm sure that I have all of the wires in the right places. So first thing that's going to get connected is going to be the negative and positive for 12 volt power for the ECSs, which is going to be this left hand, right hand, this one's furthest negative and positive, and it will be connected directly to this switch so that turning it on will turn on it turns on the Arduino and it will turn on the ECS. So once I have that plugged in, I'll be really close to being able to actually test the whole thing. But that's where we're going to start. And it's going to get soldered directly onto here, and that will kind of be the anchor point for this. Most of these are then going to be cut a little bit or possibly not at all. But the signal wires that will be connected to them will be. And there'll be a lot of heat shrink, and it'll be a whole thing going on up in here. But we will start with these two. So here we go. All right, good news. Oh no, I'm fogging up, I think. Good news though, hitting the heat shrink with the heat gun did in fact tighten it all up, and I can actually tell which wires are now which ones just because of the heat shrink shows that quite nicely. So we're good to go there. No worries about hopefully miswiring. All right, that is everything in, and Lord, that cable management is lovely. It is so much cleaner than it was before. Very easy to tell where all the pins need to go. The one thing that I may do different, I definitely need to label these because all of the yellows are by signal wires, but they're, I mean, I know which ones are which, and I know where they go if I think about it really hard, but I definitely need to label them. And figure out which ones they correspond to on this side, which will require just a little bit of testing. So I need to go get some more test cables, because they all went in for more prototyping. And then we'll give it a test. 1 minute. Well, you don't have to wait. Editing's magic! Alright, let's test and see if everything works. We flip this switch. Arduino came on, that came on, motors came up completely. You saw that this light now works, which is our overdrive. If we hit the rev, it spins, overdrive goes higher. If we pull trigger, nothing happens unless we're revving. I don't know if you can tell, but the pusher motor there is spinning. We are golden. So that is this side of the blaster 100% now wired up. The only thing that still needs to get added back in would be the hose, which is around here somewhere. And that I'm good to go. Next time, we'll wire up this side with this. So right now everything's just connected with pin wires and it's a big old mess. We're gonna make it as svelte as this is. This is some lovely cable management we have going on in here. I am pleased with it. I used electrician's tape to mark all of the ends so I will know what needs to get wired to what. Actually, I'm gonna label a few more things actually. Okay, I got everything labeled so I will easily be able to tell what gets wired to what on the far end. Now, interestingly, we have 2 red and black and 2 yellow and blue that are currently not being used for anything. So those channels are open for potential future use. I might use them for another LED. One that I'm definitely considering for the red and the black would be muzzle flash. It would not, well, it might take a little bit of work to actually mount an LED in somewhere so that it could flash that wouldn't get in the way. There's not a whole lot of room up there. But something up there that would, you know, make a muzzle flash. I might make an attachment that just gets attached if I'm using it for purely cosmetic purposes, and I'm not actually going to be firing anything from it. I could then have something that gets wired up to there. For signal, I do still have 2 locations on here that could very easily, are clearly supposed to be buttons, and that I could in fact turn into buttons. One down here, and I'm considering putting a little toggle switch in here that would activate a flashlight that would be mounted down here. That wouldn't actually require going all the way back to here because I would just use a momentary switch for a flashlight that would just get wired up to there. And I could make it something that plugs in with a jack so I can change it out or whatever. But I could have something here that toggle it and it turns on a gizmo down here, a flashlight, or you know, I could make it so it fires some sort of a master key if I really want to. I've got rail down here, I can connect whatever I want. And then this upper one I could turn into potentially put in a PWM and have a variable rate of fire. Or I could just have a switch like this one that goes from a high rate of fire to a lower rate of fire, just 2 rates of fire. That would be very simple. And I would already have the channels wired that would allow me to activate that switch on or off. So there is some upgrade capability for the future should I want to add more things like I did with this. I've got the channels, they're already in there. They're currently just in here going to nowhere, and I could wire them up to wherever they need to go. So, train? That's been going right for a while now, and I just noticed. Anyway, that's where I am so far. It is coming together beautifully. It is already far, far nicer, more elegant, sturdier, better designed than the previous design was. I might need to wrangle these cables back here just a little bit when I go to put the shell on, because they are encroaching on a post there. Maybe I could send half of it over the top and the other half underneath and get around it. That looks like probably the best option right there. Yeah, there we go. Now it looks like it'll be easy to get the other side of the shell on. Anyway, things are going good. I am currently still planning to go with the rewiring the old proton pack up with the old system and have it just be powered by the blaster. I ran some tests trying to adjust the threshold on the current sensor on it, and it wasn't working out. The amount of power drawn by 2 ECSs and an Arduino was enough that if I dialed it so that those didn't flip it, then my Jupiter also wouldn't flip it. And there's no point if I can't make it modular. If it won't work with other blasters, then it might as well only work with the one. So that's the plan. I will probably just go back to making that one a dedicated pack for this one, and use the fancy one that I had in there and just build another smaller travel one. So yeah, that's the plan. We will see how it works out. The stuff that I've learned from this and from additional Arduino work that I've been working on and looking at materials and gizmos and parts that exist, a whole new world of possibilities has been opened to me. And I'm already tinkering with all kinds of stuff that I can now do that I couldn't do before, and combining that with some other knowledge that I recently learned from the inestimable Dr. Pews. It's gonna be a good year for modding for me, I think. I'm gonna build some stuff that I've been wanting to build for a long time, and it should be pretty excited. I'm excited anyway. We'll see how it actually turns out. But there we are. That's where we're gonna leave off today. Thank you all for watching.